Okay, let's just dive right into this. Welcome everyone to this explainer on the state of artificial intelligence in 2026. Look, we all know we're standing on ground that's shifting at absolute lightning speed, right? So today we're going to take a really fascinating journey together. We'll start big, looking at the intense global competition that's shaping the industry right now. Then, we're going to pop the hood, zoom all the way down into the actual code, and figure out how these intelligent models are practically built and trained today. And finally, we'll zoom back out to look at something deeply profound, how this technology is fundamentally changing human agency. It's an incredible story, so let's get started.
Here is our quick roadmap for today's explainer. We're starting with the global AI race, then moving into tweaking the architecture, the 3 stages of training, the rise of AI reasoning, and wrapping up with AI and human agency.
Section 1. The global AI race. You know, right now there is this massive, and I mean massive, geopolitical and commercial rivalry defining who builds, controls, and deploys the most capable AI. On one side of the ring, we have the US ecosystem. This is completely dominated by tech giants like OpenAI, Google, and Anthropic. They're incredibly well-funded, and they're largely building what we call closed-weight models. That means their underlying code and parameters are kept entirely secret, and they're basically monetized through high-cost enterprise subscriptions. Essentially, you're paying a premium for peak intelligence. But on the other side, the Chinese ecosystem has taken a wildly different path. It's heavily defined by open-weight models. This is where the weights are just released out into the wild for developers to download, run, and modify globally. Companies like Z.AI, Minimax, and Moonshot are driving this rapid, almost Wild West style of innovation. They're capturing global mindshare simply by letting absolutely anyone build on top of their work locally.
And that Wild West innovation? It was kicked into absolute overdrive by the DeepSeek moment of January 2025. Honestly, this was a total shock to the system. DeepSeek, which is a Chinese lab actually backed by a hedge fund, released an open-weight model called DeepSeek R1. The bombshell here was that they proved they could achieve near state-of-the-art performance, literally going toe-to-toe with the massive US closed models, but using just a tiny fraction of the compute and financial cost. It proved once and for all that peak AI wasn't just reserved for a handful of hyperscalers with billions of dollars. It completely opened the floodgates for developers worldwide.
Section 2. Tweaking the architecture.
So how are they actually building these incredibly capable engines? Well, here's the crucial point, and it might surprise you. Despite the massive leaps in capability we've seen, AI architectures are not actually entirely new every year. In fact, we are largely still building on the exact same original transformer lineage from models like GPT-2. If you look at the fundamental architecture of the newest, smartest models today, it's pretty much the same autoregressive transformer shape. The massive gains in intelligence aren't coming from throwing out the blueprint. They are coming from researchers turning very clever, highly optimized technical knobs on that existing blueprint.
One of the absolute biggest technical knobs they've turned is called mixture of experts, or MO. Think of a standard neural network as a massive corporate team where everyone works on every single problem at the exact same time. That's called a dense model, and it is incredibly expensive and slow to run. Mixture of experts is a brilliant routing system. Instead of activating the whole network, an internal router looks at your prompt and sends it only to specific, highly relevant neural network experts within the model. So if you ask a coding question, it literally only routes to the coding expert. This makes the model sparse, which means it saves huge amounts of computing power while still holding a massive amount of total knowledge.
Alongside MOE, labs are squeezing out every drop of performance using marginal innovations. We're talking things like multi-head latent attention, optimizing the KV cache to handle massive book-length documents, group query attention, and sliding window attention. Now, you don't need a computer science PhD to understand the main takeaway here. These are all highly specific efficiency tweaks. They are designed to stretch computational limits as far as they can go without fundamentally altering that core GPT-2-style transformer shape we just talked about.
Section 3. 3 stages of training.
Okay, so now that we have the architecture down, how do we actually teach the thing? How does raw, messy internet data become a highly capable reasoning machine? Well, the pipeline is structured into 3 distinct tiers. Stage 1 is pre-training. This is where the model reads trillions of words, essentially downloading the entire internet, just soaking up raw knowledge and learning the statistical patterns of how human language works. Then, stage 2 is mid-training. Here, the model gets specialized. It learns how to handle super long contexts, like reading entire code bases or legal briefs in one go, without forgetting what it just read on page 1. Finally, we hit stage 3, post-training. The model already has all the knowledge from the internet, But post-training is where we actually unlock its skills. This is where we teach it to be a helpful assistant, to format its answers nicely, and to actually apply what it knows to solve real problems. To really grasp the staggering stakes and the sheer cost of that very first stage, pre-training, look no further than the absolutely mind-boggling $1.5 billion lawsuit that Anthropic faced over copyright infringement. This was allegedly for using pirated books in their training data. Finding high-quality data to feed these massive models during pre-training is just incredibly expensive and legally fraught. The data is literally the lifeblood of the AI, and the ongoing battle over who owns it and who is allowed to train on it is going to completely define the future of the entire industry.
Section 4. The Rise of AI Reasoning.
Now, this is where things get truly wild. We are currently migrating away from fast models that just eagerly spit out the first word that comes to mind, to slow models that actually stop, pause, and think. The engine behind this new thinking AI is called RLVR, or Reinforcement Learning with Verifiable Rewards, and this happens in that post-training phase. Instead of human graders constantly telling the AI if it did a good job, we give the AI tasks where the answer is objectively verifiable, like math equations or software code. The AI tries to solve it over and over through trial and error. If the code compiles or the math checks out, it gets a reward. It literally learns to optimize its own intelligence through rigorous self-grading.
And the result of this RLVR training? It led to what AI researchers call the aha moment. Without ever being explicitly programmed to do so, the models began generating a hidden scratch pad of thoughts before answering the user. Just like a kid showing their work in a math class, the AI started reasoning step by step. It would write out its logic, catch its own mistakes, actively self-correct, and try a completely new path before finally giving you the polished answer. This hidden chain of thought has massively, almost unrecognizably, unlocked the model's ability to solve incredibly complex logical problems.
Section 5. AI and Human Agency.
Let's zoom back out from the code for a second and look at the macro level. How are these highly capable, thinking models actually impacting the humans who use them every single day? In a recent survey of 791 senior professional software developers, we're talking people with over a decade of experience, a massive portion of them reported that more than 50% of the code they are actively shipping to production right now is AI-generated. The models have become so incredibly good at reasoning and tool use that top-tier human experts are comfortably delegating half their workload to the machine. Which poses a really deep, kind of uncomfortable human question. Does AI steal the joy of building? If we are delegating all the heavy cognitive lifting to machines, do we lose our passion for our crafts? Think about it. If an AI writes your code, writes your essay, or solves your complex problem in seconds, what happens to your own personal sense of fulfillment? AI researcher Nathan Lambert noted something really profound about this. He said, "Debugging is like a drink of water after you've been going through a desert for days." That really stuck with me. The painful struggle of human problem solving, that frustrating, agonizing desert, is exactly what makes arriving at the final solution feel so incredibly rewarding. If you use AI to entirely skip the desert, you might also be skipping the profound satisfaction of that drink of water at the end.
So the crucial takeaway here is that we have to find the Goldilocks zone. We maintain our agency by intentionally choosing how we interact with these tools. We absolutely should automate the mundane, tedious stuff, like reformatting links or writing basic boilerplate code. Get that off your plate. We can use AI as a collaborative pair programmer to bounce ideas off of. But, and this is critical, we must fiercely protect our time for offline struggle. We have to carve out spaces where we wrestle with complex problems ourselves so we maintain our deep, intuitive understanding of the systems we're actually building.
And that leaves us with this final, critical thought. As these AI capabilities continue to just explode in 2026, the choice is entirely yours. Are you going to passively let the machine do the thinking for you, ultimately surrendering your own skills? Or will you actively use this incredible technology to amplify your human agency, pushing your craft further than you ever could have before? Thank you so much for joining me on this explainer. Keep learning, stay curious, and I'll see you next time.